Okay, so when we left off, we were working on number 10 from page 571, and we were just finding the work function of the metal. And when you do 6.626 times 10 to the negative 34 times the threshold frequency, 6.7 to the 14th, you get 4.43942 times 10 to the negative 19 joules. Okay? Now, this isn't going to change through part A or part B because you're keeping the metal the same, you're changing the light. So in part A, the wavelength of light that's coming in is 350 nanometers. So knowing that C equals F lambda, we can get the frequency of that light, C divided by lambda. So 2.9979 times 10 to the 8th meters per second divided by 350 times 10 to the negative 9 meters. And we get a frequency for the first part to be 8.565 times 10 to the 14th hertz. So once we have this, now we can find our maximum kinetic energy. Okay, so it's EK max is equal to HF minus WO. So EK max is equal to 6.626 to the negative 34 joules seconds. F was 8.565 to the 14th hertz. And our WO is 4.43942 times 10 to the negative 19 joules. And when you do this, you get an EK max to be in joules 1.236 to the negative 19 joules. I got to go back and look at the question because I don't know if it asks for joules or electron volts. Calculate the kinetic energy in electron volts, of course. So then divide this by by 1.602 times 10 to the negative 19 and get a kinetic energy of 0.77156 electron volts. Okay, so again you're dividing 1.602 to the negative 19 joules per electron volt. No. And then when you're dividing by that, the joules will cancel out and you'll be left with electron volts. All right, there's a part B that says the frequency of the light being shone in now, or the wavelength, is 550 nanometers. So again, C equaling F lambda. F will equal C over lambda. So 2.9979 times 10 to the 8th meters per second divided by 550 to the negative 9 meters. You will get a frequency of 5.451 times 10 to the 14th hertz. So now you go back over and you do EK max again. Is equal to HF minus WO. So EK max is equal to, again, 6.626 times 10 to the negative 34 joule seconds. F this time is 5.451 times 10 to the 14th hertz minus your WO is the same one, 4.43942 to the negative 19 joules, and you will get an EK max of negative 8.2777 times 10 to the negative 20 joules. Now what the heck does the negative mean? The negative means WO is bigger than the energy of the photon coming in. It means that an electron won't be emitted because the the energy coming in isn't big enough. Okay, so this negative means no electrons ejected or emitted. Okay, if we go back and look, we were given the FO up here, the threshold frequency, it was 1.6. When we found the frequency of the second light on part B, it was smaller than it. And so right away we could have, maybe if we were looking, recognized that there's not going to be anything emitted because you're not above that threshold frequency. Okay, that was number 10. It was kind of nice, wasn't it? Number 11 says the work function of iron is 4.7. Can't find the edge of my page. There it is. So WO is 4.7 electron volts. What is the threshold wavelength? So for A, we know WO is equal to HFO. So FO is equal to WO divided by H. So 4.7 electron volts divided by 6.626 times 10 to the negative 34 joules seconds. And as soon as you write down that joules and electron volts, you're like, oh, I need to switch it. 1.602 to the negative 19 joules per electron volt will allow us to switch it to get just joules, and then we can divide by joules seconds. And when we do, we get a threshold frequency of 1.1363 times 10 to the 15th hertz. Okay, don't remember what the question asked. What is the threshold wavelength? So once you have the threshold frequency, then C is equal to F lambda. So lambda O is equal to C over FO. So 2.9979 times 10 to the 8th meters per second divided by the 363 times 10 to the 15th hertz. And when you do this, you get an FO of 2.638 times 10 to the negative 7 meters. Answer to part A. Part B wants to know iron is exposed to radiation of wavelength. So now in part B, they're telling us the wavelength of the radiation is 150 nanometers. So knowing C equals F lambda, we can find our F. C divided by lambda, so 2.9979 times 10 to the 8th meters per second divided by 150 times 10 to the negative 9 meters. And we get a frequency of 1.99686 times 10, got this number before, the 15th hertz. Okay, and then it says, what is the maximum kinetic energy? So EK max is equal to HF minus WO. So EK max is equal to 6.626 to the negative 34 joules seconds times, what was that? 1.9986 to the 15th hertz minus WO. So if we go back, somewhere we had a WO. It was 4.7 electron volts. So because I didn't write it down, I have to multiply again by 1.602 to the negative 19 joules per electron volt so that I get both in the same unit. Oh, I should have switched the other one to electron volts though, because it's asking for it in electron volts. So scratch this and divide this one by 1.602 times 10 to the negative 19 joules per electron volt. And when you do that, the first term is 8.2664 electron volts minus 4.7 electron volts. You should end up with an EK max of 3.566 electron volts. Now you could have done what I was about to do and switch this to joules, get your final answer, and then divide by 1.602 times 10 to the negative 19. It would work out to be the same. Okay, I just didn't want to multiply and then divide in the end. I was trying to save time. All right, there are your homework questions.